Air quality information is easier than ever to access online, but if you want to know how the air quality measures up between two different classrooms or two different streets, you can use PASCO's wireless air quality sensor to find out. Accurate air quality assessments include meteorological conditions as well as airborne pollutant concentration data. The pollutants measured by the wireless air quality sensor include ozone and nitrogen oxides and volatile organic compounds, or VOCs. Also particulate matter with a diameter between 10 microns to just above 2.5 microns, from 2.5 microns to just above 1 micron, and 1 micron or less, also called PM10, PM2.5, and PM1 respectively. The sensor also reports temperature and relative humidity. To help with experiment design, we label the vent where air enters the sensor as inlet, so you can orient the sensor towards a point source. This is the exhaust vent where air exits the sensor. Make sure both of these vents are open to the air when you use the sensor. You can use the sensor in any orientation that does not block these vents. Most PASCO gas concentration sensors require just a couple minutes of warm-up time, but for the wireless air quality sensor, you'll get the most accurate data with at least 20 minutes of warm-up time. There are two different ways you can warm up the sensor. You can either connect the sensor to your PASCO software and collect a 20-minute run of data right before your experiment, or if you're familiar with logging mode, you can log data for at least 20 minutes, then connect the sensor to your software and start collecting data right away. If you are specifically interested in ozone or nitrogen oxide measurements, warm-up time may take longer than 20 minutes. Monitor that measurement in a graph display so you can see when the reading stabilizes and you can calibrate it at that time. The wireless air quality sensor works with SPARKvue, ChemView, or Capstone software. I'm using SPARKvue. When I connected the sensor, I chose the Monitoring Air Quality Quick Start experiment, and that's how I got this two-page display that shows the mean or average values for the measurements updated every second, plus a graph display on the second page. You'll probably want the average values, but if you want to see real-time values, you can turn off the averages or on as needed. As you can see, I have already been recording for at least 20 minutes, so the sensor is warmed up. I'll stop collecting data. Now here's a question I'd like to answer. What is the air quality like in this room right now? And how do I interpret the numbers I get from the sensor? Let's start a new run where I leave the sensor undisturbed to collect baseline data for the initial air quality conditions inside this room. I'll record data for 5 minutes, and we'll speed through the baseline run for you. We'll need the help of the airnow.gov website to interpret these numbers. Go to a browser and search this phrase, Airnow Air Quality Calculator, and pick the calculator website with the .gov at the end of the web address. Then choose Concentration to AQI. Choose a pollutant. Notice VOCs and PM1 are not in here, and that's because the United States Environmental Protection Agency, or EPA, has not established standards for these pollutants. Looking back at our data, you'll see ozone and nitrogen oxides reported as a single measurement. You can use the same value for both of those measurements in the Airnow website, so it's 0 ppb. If I choose ozone 1 hour average, and enter the 0 concentration value from my data. Calculate. I don't get an answer on the AQI category here, but the website gives me guidance on how to make my data work. It says right here, I need to use the 8-hour average for values below 100 ppb. So let me change it to 8 hours. and then enter the 0 concentration. Good. According to Airnow, if conditions remain unchanged, the ozone level in this room is currently good. You're probably thinking though, wait, I only have 5-minute averages, but Airnow uses longer averages. Well, it turns out air quality measurements are typically collected over longer periods of time. So when you design your air quality investigation, consider the time available to collect data and recognize the time limitations you have. Or if possible, collect data for the air quality parameters over the time frames specified on the Airnow website. Let's look at VOC data. As you can see on the page 2 graph, the VOC measurement takes a while to stabilize for every run, even after warm-up. So it's best to select the portion of data that has reached equilibrium. That's over here. And use the statistics tool to apply a mean through the most stable data. Now, what happens to air quality values when I set an open dry erase marker near the inlet? To find out, I can start a second run and collect data for 5 minutes so I can compare the results against the baseline air quality measurements from the previous run. This investigation is available in PASCO's experiment library. The Testing Air Quality Lab provides the procedure on how to perform the investigation, along with plenty of helpful information about air quality parameters, what they are, how to interpret sensor measurements, and how PM1, 2.5, and 10 particle sizes compare to one another. You'll have to complete the investigation to find out how a dry erase marker affects air quality.